Assalamu alaikum. I'm Sunil Khan and my partner is Amna Muzaffar and our topic is code injection attack. This is our agenda. We'll be discussing the introduction, literature review, problems identified, comparative analysis, implementation tools, recommendations, conclusions, and the future work. Let's start with the introduction of the topic. What basically are code injection attacks? It is the malicious insertion of unauthorized code into vulnerable software systems. And this mostly exploits the weaknesses in the input validation mechanisms and it manipulates the behaviors of the target applications. This often is used to gain unauthorized access to the data, escalating the privileges and executing arbitrary commands. The prevention and detection of these code injection attacks is considered of high importance in cybersecurity, like prevalence and ease of exploitation, as most of the SQL injection attacks and cross-site scripting is these are kind of the most important security issues found in the web application. Similarly, they are potential for severe damage. They have potential of severe damage and they have impact on reputation and trust, legal and regulatory consequences, and complexity of modern applications. I'll briefly discuss how these injection attacks work and what past work has been done to prevent and detect these attacks. SQL injection attack. SQL injection attack basically exploits the vulnerabilities in the web application by inserting specially crafted SQL queries. How it's done? Attackers manipulate the SQL queries by inserting some arbitrary SQL code into the query, and obviously this is done through inputs that are not properly sanitized. Commonly, the targets of these SQL injections are the web applications that communicate with the databases. In the past, there has been a lot of work done regarding these SQL injection attacks, and some of the machine learning and deep learning models, including the neural networks, have shown accuracy in detecting these SQL injection attacks. Rule-based system, intrusion detection system, and signature-based detection, input validation, parameterized queries, use of prepare statements, and Diava. It uses the traffic analysis and multi-level regular expression models to detect SQL injection. It has outperformed traditional uh, models and all that in terms of precision and recall. SQL injection attack. Unlike the SQL injection attack, these no SQL injection attacks are done on those databases that operate on NoSQL, like the MongoDB. The attackers inject those malicious codes into the queries that target NoSQL databases, and most of these databases often use JSON similar formats, so it makes injection attacks possible through user input. Now, despite the performance of and flexibility of these models using NoSQL databases, they are more vulnerable to attacks due to the inadequate input validation and use of different query languages. Now, previous work has also been done regarding these, like the symmetry encryption RSA can prevent the NoSQL injection by ensuring that only decrypted legitimate queries are executed at the database server. And we can also introduce middlewares which, between the clients and the servers, which can sanitize the inputs and validate the queries at the runtime effectively. And LDAP query injection attacks. XPath injection attack is basically where the attacker injects malicious XPath queries into the web application's XPath query processing. Now, the attacker injects the code into the application that constructs the XPath queries based on the user input, and mostly these user inputs are not properly sanitized, which allows the attackers to manipulate the XPath queries. LDAP, which stands for Lightweight Directory Access Protocol. It is also an injection attack where malicious LDAP statements are inserted into the query to manipulate the LDAP directory services. Again, the attacker injects the code into the application that builds the LDAP. The query is based on user input, and these user inputs are again not properly sanitized, which allows the attackers to alter the LDAP query. Now, there has also been work related these LDAP queries and XPath injections, like the pattern matching and grammar analysis are used to detect injection attacks by analyzing the structures. LSTM networks are also used in some models to detect these injection attacks. Cross-site scripting or XSS. Basically, the attacker injects malicious scripts code into the trusted web pages. Attacker uh, injects those scripts into the web pages that are viewed by other users. These scripts run in the context of user's browser and allowing the attacker to steal the information or perform actions on the behalf of the user. There are different types of XSS like the stored XSS, reflected XSS, DOM-based XSS, and a lot of work again has been done regarding to detect and prevent this cross-site scripting. Like a lot of models have used reinforced learning, random forest, logistic regression, k-nearest neighbors, extreme gradient boost, etc. XSS detection on the server side and XSS auditor in Google Chrome has been proposed to enhance the security. Web application firewalls, intrusion detection systems, intrusion prevention systems, along with content security policies, also provide prevention of XSS attacks.
Okay, so I will start with a comparative analysis of advanced detection and prevention techniques. So, if we start with detection techniques, then there are two main detection techniques in code analysis, code injection analysis. So, that is static analysis and dynamic analysis. So, here is a comparison between them, the main differences between both of them. So basically the static analysis is basically in the early software development life cycle, like when we are detecting code injections attacks in the early life cycle, then we are dealing with the static analysis. But if we are dealing it at a runtime environment, like during the execution of program, then it becomes a dynamic analysis. And there are a number of tools that are used for static and dynamic analysis, including SonarQube, Findbugs, Checkmarks. While in dynamic analysis we have a burp suit. Also we can say that in a static analysis, basically we are identifying coding errors, like insecure coding practices, while in dynamic analysis there are a lot of things that were missed by the static analysis and that are dealt in the dynamic analysis, including a runtime environment and configurations. Also, there are basically static analysis is implemented in CI/CD pipelines, while in dynamic analysis we are dealing in the later stages, basically during the testing and quality assuring phases. Now, if I talk about the runtime protection, then basically it is a prevention technique for code injection attacks. It basically use web application frameworks to filter HTTP requests, and it basically identify and block the malicious requests that may contain injection payloads. There are a lot of methods for the prevention, including intrusion detection systems and intrusion prevention systems. So basically, they block the code injection attempts and also filter the malicious traffic. Moving towards the implementation tools, then there are a number of tools that are basically in the market and in the industry that are basically very useful in code injection detection and prevention. These are the five main implementation tools, including a SonarQube, BurpSuite, Mod Security, OWASP, and Checkmarks. So basically, a SonarQube is a static analysis tool. Basically, it inspects a code and then it detects the vulnerabilities in it. Also, BurpSuite is a tool for the dynamic analysis, and it basically uses a filter HTTP request and a CID pipelines. And mod security is also related to web application firewalls. Basically, it monitors HTTP traffic and it basically reduces the risk of code injections. OSZAP is also a dynamic tool that is basically using in a spider for crawling applications. Checkmarks is also a security testing tool. Basically, it detects security vulnerabilities and also command injections and XSS attacks. So the problems mostly I identified in my research work was that, as I discussed before, that there are two types of analysis, static and dynamic analysis. So the main problem with the static analysis is that it making a lot of false positives, thus making it prone to oversight, while dynamic analysis is basically not evident at runtime. And also I have discussed about web application firewalls, but the issue with that was that the attackers are using up many bypass mechanisms, so it is not really effective. So now if I talk about the recommendations regarding this, so I can say that there are number of tools that I have discussed before. We can use them in our development pipelines, so in order to ensure security. Also, with the help of machine learning and AI, we can enhance our security and prevent from code injection attacks. Also, regular security audits, automate security testing will help us provide better security. So, if I conclude my research, then I will say that the code injection attack is still very persistent and it is in a very evolving trend. Like in a static analysis, we are facing a lot of issues of false positives. In dynamic analysis, there are runtime issues. Also, in the prevention techniques, there are bypass mechanism for by the skilled attackers that are used. So, it is a very crucial matter to pay heed so that we can prevent code injection attacks in our daily life applications, that it is basically threatening a lot of modern applications and it is breaching our security. So I can say that a code injection attack is still very persistent and evolving. So a lot of work has been done in this field in the protection, like in implementation tools as I discussed before, and also there are a lot of basically models have been trained for the detections, but still there are some future works that can be done in order to enhance the security. So we can use context-aware security tools for the various applications. Also we can automate and integrate different types of CID pipelines to ensure the security. And I can say that using these things in a future research will contribute to more effective strategies, thus ensuring the security of our digital assets. So that's all from my side. Thank you so much. These are the references of the papers that we have used in our research, and that's all. Thank you so much.